Hey everyone, welcome back to the Deep Dive. I'm really excited for this one. We're diving into the world of minds today, and not just the ones we're used to. You know, those amazing, sometimes frustrating things inside our own heads.
That's right. We're thinking bigger, exploring the mind in all its potential forms, which is exactly what Philip Ball does in his book, The Book of Minds. It's a real deep dive into what a mind even is, where we might find other minds, and just how diverse they could be.
And that's what we're doing today, using Ball's work as our guide to explore this mind space.
Yeah.
Buckle up, because we're going to journey from those assumptions we all have about minds to the intelligence of animals, then on to those artificial minds we're building in machines, and even the possibility of minds existing out there in the vast universe.
Exactly. And get ready for some serious mind-expanding moments along the way as we challenge some common assumptions. So to start, what is a mind? It's so easy to just assume, well, if something acts like us, it must have a mind like ours.
Right, like it's just simpler to think others experience the world the same way we do, rather than imagining beings that act just like us, but without any actual inner experience, like some kind of super advanced robot just going through the motions.
Yeah. I mean, imagine those zombie beings Ball talks about. They can use language, they react to emotions, maybe their brains even show activity that looks just like ours, but inside, nothing. No actual conscious experience. It's a little creepy, to be honest. Makes you wonder what the real difference is.
Totally. But, it's like we also tend to see minds everywhere in everything. You mentioned animism, where people saw spirits and all sorts of natural things. Nowadays, we might think of that as a bit primitive, pre-scientific. But it does make you think, what happens when we strip away that sense of mind from the world around us? Does it change how we value it, how we treat it?
It's a good question to consider. Some argue that even suggesting plants might have minds, even if it's just an idea to help us connect more deeply with nature, makes us rethink our relationship with the environment. It's like James Lovelock's Gaia hypothesis, viewing the Earth as this self-regulating system, almost like a living organism. Whether it's scientifically accurate or more of a poetic metaphor, it highlights our deep-seated desire to find mind-like qualities in the world.
Right. But how do we define mind in a concrete way?
Yeah.
It's not as easy as you might think. It's more than just how something behaves. A thermostat can make decisions, right? Turn the heat up or down. We wouldn't say it has a mind.
Exactly. It's missing that key ingredient,
Right.
awareness, that internal subjective experience, what it feels like to be that specific thing, the what it is likeness, as Ball calls it. That's what seems to separate a mind from a simple machine.
But then how do you test for that in something else? It feels like that philosophical problem of never truly knowing if what you see is the same as what someone else sees, let alone what an entirely different being might experience. It's that whole problem of other minds.
And that's why it's more helpful to shift our thinking. Instead of getting stuck on whether other minds exist in the same way ours do, let's consider how mind emerges from our own brains. What are the essential cognitive functions that create our experience? And how might those functions appear or differ in other entities that could have some form of mind?
That's a great point. It moves us away from just asking, is it conscious, to exploring the vast landscape of potential minds based on what we know about how brains work. And this reminds me of that age-old debate about the ghost in the machine. Descartes and his idea of the mind is this separate, non-physical thing controlling the physical body.
Yeah, Descartes' dualism. And then you have Gilbert Ryle, who called that the ghost in the machine. He argued that the mind isn't this separate entity, but rather it's inseparable from our actions, from what we do with our bodies. He saw separating the two as a fundamental misunderstanding.
Right. It's like Ryan was saying, you can't understand the mind without understanding the body and how they work together. It's fascinating how this debate still resonates today, especially with everything we're learning from neuroscience and cognitive science. You can't talk about the mind without considering the brain.
And that leads us to consider the spectrum of possibilities. Back in 1984, Aaron Sloman, a computer scientist, pointed out that we needed a more systematic way to think about minds, especially with the growing fields of animal cognition and AI. His point was, and it seems pretty obvious now, there isn't just one kind of mind.
Yeah, that makes a lot of sense. We tend to talk about intelligence as if it's this one thing you can measure. But even with humans, intelligence comes in so many forms. It's like saying an IQ score tells you everything about someone's cognitive abilities.
Exactly. How someone performs on a test can be influenced by a lot of things that aren't actually measuring their core cognitive abilities. It's a huge challenge to even think about designing a test that could fairly assess the minds of vastly different beings. Think about that cognitive decathlon they tried in the 2000s. They were trying to move beyond just simple performance metrics. But even that was still a very simplified approach.
And this idea of different types of minds makes me think about those collective pseudo-minds Ball discusses. Things like corporations, they have goals, strategies, even decision-making processes that seem separate from the individuals who work there.
And that raises the question, where does that mind-like behavior come from? Is it simply the sum of the minds of the people in the corporation? Or is it something more, something that emerges from the complex interactions between those individuals? And with AI becoming more integrated into these structures, it's not hard to imagine, as Danny Hillis suggests, that corporations will design AI to further the goals of the company. Ball even points out how the actions of companies like Facebook and Google can sometimes seem, well, almost amoral. It's like they're acting in a way that no individual person would, which makes you think about how these collective entities actually think.
It's a little unsettling, isn't it? This idea of minds that aren't tied to a single biological body.
Yeah.
And that brings us to Christoph Koch and his concept of mind space. It's a way to visualize all these different minds based on their intelligence and consciousness.
Right. Cox Mindspace gives you this map of the potential landscape of minds. It's a way to think about where different entities might fit. Then you have Murray Shanahan, who added another axis, the H-axis for human likeness.
So reminding us that we tend to judge other minds based on how similar they are to our own. It's like we automatically put humans at the top, but maybe that's just our bias.
Exactly. And it's important to separate the brain from the mind. We can study brains, but the mind is this dynamic, constantly changing thing that's shaped by the brain, the environment, and experiences. As Steven Pinker puts it, behavior itself did not evolve. What evolved was the mind.
So the mind is what allows us to adapt and survive in different environments. And humans, we live in more diverse environments than any other species. Ball attributes that to our uniquely flexible intelligence. But he also mentions Wallace's paradox, this idea that our brains are maybe more powerful than they need to be. Why would our ancestors need the brain power to, say, understand advanced physics when they were just trying to survive?
Yeah, Wallace pointed out that you'd think a brain just slightly larger than a gorilla's would be enough for our ancestors to meet their basic survival needs. Our brain power seems like overkill for that. But what's interesting is that when we see this huge explosion of human culture and society maybe 40 or 50,000 years ago, with complex art and music and all that, it doesn't seem to be accompanied by any major changes in brain size or structure.
So it's like the hardware was already there, but something, maybe culture itself, triggered the software to run at full capacity. We still don't know for sure, but it suggests intelligence can evolve for reasons beyond just immediate survival needs.
And one theory is that the need for complex social cooperation was a major driving force in the evolution of intelligence. As our ancestors became more intelligent, their behavior became more complex. That created a need for even greater mental capacity to navigate those complex social interactions. And as researchers like Martin Nowak have pointed out, the best strategy for an individual in these situations constantly changes depending on what everyone else is doing. It's this dynamic interplay of behaviors.
It makes sense, right?
Yeah.
In a complex social group, being able to understand the intentions and actions of others is crucial. And cooperation, even though it can be risky, often leads to better outcomes for the whole group, like in that classic example of the prisoner's dilemma.
Right. But it's also important to recognize the huge role of cultural evolution in shaping our behavior. It goes beyond just our basic biological instincts. As Daniel Dennett put it, every human mind you've ever looked at is a product not just of natural selection, but of cultural redesign of enormous proportions.
And language, that's got to be one of the most powerful tools for this cultural redesign. It allows us to communicate such complex ideas across generations. Daniel Dorr even argues that the main purpose of language might not be just to communicate facts, but to actually instruct the imagination.
Dorr suggests that language is fundamental to the development of human imagination. He uses this great analogy from Wittgenstein. Uttering a word is like striking a note on the keyboard of the imagination. It's like we're giving each other these mental building blocks to create our own internal experience of what's being described.
That's so cool. It really captures how powerful language is, and it makes me think about how the mind is more like a pilot than a computer. We're not just processing information in a linear way, we're constantly making interconnected decisions, often without even realizing it.
Right. It's not just a simple input-output process. Living involves a continuous flow of decisions, actions, and emotions. And perception, as Ball points out, is more like a controlled hallucination. It's not a perfect recording of reality, but a hypothesis based on the available information constantly being updated as we get new data.
So our minds are always trying to make sense of the world, even if it means subtly altering our perception to fit our expectations. Like in that McGurk effect, where what you see can actually change what you hear. It's fascinating how easily our senses can be tricked. And Hume's observation that we gild and stain all natural objects with the colors borrowed from internal sentiment really captures how our minds shape our experience.
Yes, and this active process of perception is connected to affordances, those opportunities for action that the environment offers us. Our minds are amazing at spotting these affordances, which is crucial for our adaptability and even for developing technologies.
It's like our minds are constantly asking, what can I do with this? Ball also discusses those core knowledge systems proposed by Elizabeth Spelk.
Mm.
These are innate intuitions about things like objects, space, and numbers that develop into what she calls an intuitive physics engine. It's almost like we're born with a basic understanding of how the physical world works.
Right. It allows us to make predictions about cause and effect, but it's important to remember that these core intuitions aren't always right. It's where the scientific method comes in, to refine our understanding and avoid confusing correlation with causation. Just because two things happen together doesn't mean one caused the other.
It's so easy to jump to those conclusions, though. And then there's a whole area of intuitive psychology and the concept of theory of mind, our ability to understand that other people have their own thoughts, feelings, and beliefs, which might be different from our own. You know, that experiment with the grapes and the cups, it so clearly shows how kids develop this ability.
Yeah, in that experiment, kids initially struggle to grasp that someone else might not know what they know. Once they develop theory of mind, they understand that others can have different beliefs, even if those beliefs are wrong. And emotions, well, they're deeply intertwined with all this. It's not just that they can cloud our judgment, they're a fundamental part of our embodied mind, providing us with drives and motivations. As Steven Pinker says, the emotions are mechanisms that set the brain's highest level goals. And Hume, well, he believed our passions are at the root of all our actions.
It's like in that beans on toast or roast dilemma Ball talks about. Sometimes our emotions just override logic when making decisions. And it's hard to imagine a person without any emotions, like Spock from Star Trek. It feels almost inhuman because the emotions are so deeply woven into how our minds work.
Right. It makes you think about conditions like psychopathy, where there's a real disconnect between emotions and actions, or the different ways individuals on the autistic spectrum experience and express emotions. It underscores how essential emotions are for understanding the human mind.
It's a good reminder that it's so hard to truly grasp what someone else is feeling, even if we can understand their actions. This whole debate about whether labeling an emotion is necessary to actually feel it just shows how complex and nuanced our internal mental states are.
Exactly. And that leads us to the idea of neurodiversity. It challenges the idea that there's one normal human mind. Differences in brain wiring and function, especially those associated with autism, are seen as natural variations, not deficits.
Yeah, and that's so important. Simon Baron-Cohen's work on empathizing and systematizing brains is fascinating. He suggests autism might be an extreme form of the systematizing brain, which could be a real driving force for innovation and discovery. We need to be careful not to devalue these traits just because they don't always fit our social norms.
Baron Cohen suggests individuals with a strong drive to systematize, to find patterns and rules, might have played a huge role in human advancement. Uta Frith adds to this by pointing out that although some autistic individuals show extraordinary talents, they can be very specific and might not necessarily be a sign of an entirely different type of mind.
So it's not just about how intelligent someone is, but how that intelligence is expressed.
Yeah.
And it's interesting to think about how our minds often use shortcuts and filter out information to avoid being overwhelmed. Even memory is not perfect, but that might be a good thing. Borges' story Funes the Memorious shows how total recall can be paralyzing.
And not all human behaviors can be explained solely by evolution. We do things that are pointless or even harmful sometimes. It might just be the price we pay for having such complex, adaptable minds.
Okay, let's tackle one of the biggest mysteries of the mind, consciousness. It seems like everyone has an opinion about it. Some see it as the holy grail of neuroscience, others call it a distraction. George Miller even suggested we should ban the word consciousness temporarily, just so we can find more precise ways to talk about it.
One of the most famous arguments against the idea that consciousness is simply a matter of computation is John Searle's Chinese room thought experiment. Imagine a person in a room following rules to manipulate Chinese symbols. They can pass messages back and forth, appearing to understand Chinese. But Searle argues they don't actually understand anything. They're just following instructions. It challenges the idea that just simulating a process is the same as actually experiencing it.
Right. And then we have more formal theories like integrated information theory or IIT,
Mm.
which try to define consciousness in a very specific way. Can you unpack that a bit for us?
IIT, developed by Tononi and Koch, basically says consciousness isn't an on-off switch, it's a matter of degree. They use the Greek letter phi, I, to represent this degree of consciousness, which they say depends on the complexity and interconnectedness of a system. So any system with the right kind of structure could have some level of consciousness, even if it's very basic. A complex system like the human brain would have a very high degree of consciousness, while a simple organism might only have a tiny bit.
So it's not just about whether something is conscious, but how conscious it is. That's pretty different from something like global workspace theory, isn't it?
Yeah. Global workspace theory focuses on the front of the brain, those areas involved in attention and decision-making. IIT, on the other hand, points to the back of the cortex, those areas involved in processing sensory information. They believe those areas have the right kind of structure for the high levels of integrated information that they think are necessary for consciousness. It's worth noting that we don't have it all figured out. There's still debate about the role of different brain regions, like the thalamus. And just because we see brain activity that correlates with a conscious experience, it doesn't automatically mean that activity is causing that experience.
So it could be that multiple parts of the brain work together to create our unified experience. It's fascinating to think about how it all comes together. And most theories suggest consciousness serves some important purpose, like helping us organize our thoughts and make decisions.
Yeah. In this context, Ball defines mind as something for which there is something it is like to be them. It implies some level of awareness, and he makes a point that consciousness might not be essential for complex cognition. So the realm of potential minds might be even broader than just those that are conscious in the way we understand it.
Which brings us to animal minds. It's so hard to even imagine what it's like to experience the world through the senses of a bat or a dog or an octopus. Thomas Nagel asked that famous question, what is it like to be a bat? It highlights how difficult it is to truly understand another being's experience, especially when it's so different from our own. Do animals even have a sense of self, or can they understand the minds of others in their own species?
It's a huge question. And our views on animal minds have changed a lot over time. Think of Descartes, who believed animals were basically just complex machines without any real inner experience. That led to some pretty wild ideas, like using pigeons to guide missiles. But now we're starting to appreciate the complexity of animal intelligence.
And it's incredible to think about how differently animals perceive the world. Jakob von Uexküll's concept of the Umwelt is a great way to illustrate this. Can you tell us more about that?
The Umwelt is basically the sensory world of a particular animal. It's all the things they can perceive and that are meaningful to them. For example, bees see ultraviolet light, which we can't. Bats use echolocation to navigate, and dogs have an incredible sense of smell. Their reality is shaped by these unique sensory experiences. It's a good reminder that our human way of seeing the world isn't the only way or necessarily the best way.
That's a good reality check. Ball also warns against judging animal intelligence by our own standards. We tend to focus on those rare intelligent behaviors and ignore the everyday actions that might be just as revealing about their minds.
It's like what Thorndike said. We pay attention to the intelligent and unusual, but overlook the stupid and normal. One thing that seems to set humans apart is our ability to generalize our intelligence. We can apply what we know to a huge range of situations, leading to much more flexible behavior compared to most animals. That flexibility might be tied to our consciousness and our ability to imagine different scenarios.
And the research on primate problem solving is really cool. They've found that there are different levels of understanding. Like, a chimpanzee can learn to pull a string to get food, but they might struggle if the string is broken and they have to use a tool to fix it. It suggests they don't always grasp the underlying cause and effect. Complex social cognition, like theory of mind, is often seen as a key difference between humans and other apes. But Franz de Waal has shown that chimps can display empathy and cooperation that go beyond just being selfish.
Yeah, primate social intelligence is still being explored. And don't forget birds. Crows, ravens, and parrots are incredibly intelligent. Nicola Clayton's work with New Caledonian crows shows they can plan ahead and use tools in a way that was once thought to be unique to primates. And their brains, especially the pallium, are packed with neurons, suggesting a higher capacity for complex thought than we used to think. Some studies even suggest a sense of self-awareness in crows.
That's incredible. And what about something like the waggle dance of honeybees? That's a pretty sophisticated way to communicate the location of food.
Definitely. It shows they can communicate direction and distance. And there's evidence they might even have mental maps of their environment. They've been known to fly directly back to their hive or a food source, even after being captured and moved to a new location. And Churchland's work suggests that animals have internal states of mind that influence their behavior. It could be a very early form of sentience.
Antonio Damasio argues that our complex emotions require a sense of self. So animals that don't have that might experience pain but not suffering in the same way we do. It's a different view from someone like Nabokov, who saw a vast gap between apes and humans because of our self-awareness. And it's fascinating to see research exploring things like optimism in animals, those studies showing bumblebees responding positively to certain colors associated with rewards.
Yeah, that research suggests internal states that are more than just simple responses to stimuli. And what about the mating displays of bowerbirds? They build elaborate structures to attract mates. Darwin and von Frisch wondered if those displays involved a genuine aesthetic response in the females. It makes you think about the origins of beauty and appreciation. And now we're using AI to decode animal communication, like the WhaleX project trying to understand whale songs.
And octopuses. Those are fascinating creatures with unique nervous systems. You mentioned they might have weak proprioception and a sense of self-taste for their arms.
Yeah, they're incredible. It seems their brains are much more distributed than ours. Each arm has a sort of mini brain that controls its movements. Godfrey Smith argues that this raises questions about the unity of their experience. It's like their sense of self might be very different from ours.
So, taking a big step back, what's the basic evolutionary purpose of a nervous system? Why did it even develop in the first place?
The main function seems to be sensing the environment and coordinating movement, especially for organisms that move around. If you compare them to those early stationary life forms, it's clear that active interaction with the environment requires some way to process information and control movement. But those systems are costly in terms of energy, so they only provide an advantage when an organism's behavior becomes complex enough.
Which brings us to Ginsburg and Jablonka's ideas about how minds emerged. They propose that a simple sensing and control network becomes a mind with sentience when those neural patterns start to be associated with positive or negative feelings related to survival. It's like the first spark of feeling, the beginning of basic consciousness.
And associative learning is key here. It lets organisms connect new sensory information with those internal states, allowing them to adapt their behavior. Those feelings become internal guides for what's good or bad for their survival.
The idea of plants having minds is definitely thought-provoking. Darwin even noted the purposeful behavior of plants. Think about the Venus flytrap, which can count electrical impulses before closing its trap.
While plants do exhibit complex signaling, it's important to distinguish that from feeling pain as we understand it in animals. Plant neurobiology is an interesting field, but it's still debated. Some argue that it oversimplifies neural processes, but it is interesting that plants use molecules that are similar to neurotransmitters in animals.
And there are arguments being made for a kind of mind in fungi as well, with those vast, interconnected networks of mycelium.
Yeah, the way those networks communicate is fascinating. Ultimately, the question of plant and fungal minds is still open, but it forces us to reconsider our definition of mind. Feinberg and Mallet proposed some criteria for primary consciousness, but it's mostly focused on animals with a central nervous system and brain.
And then there's biopsychism, the idea that sentience is a fundamental property of all living things.
Biopsychism, as argued by Varela and Maturana with their concept of autopoiesis, suggests that sentience might be inherent to life itself. Reber even suggests this view bypasses the whole problem of explaining how mind arises from non-minded matter, but you have to be careful about defining mind so broadly that it loses all meaning.
Now, switching gears to machine minds, we can't ignore the warnings from people like Stephen Hawking and Elon Musk about the potential dangers of advanced AI. But this quest to build thinking machines goes way back, right, to those mechanical calculators and Babbage's analytical engine and Ada Lovelace's work on programming.
Absolutely. And the early AI pioneers were so optimistic, thinking we'd have human-level AI in no time. But it turned out human cognition is way more complex than they thought. That led to the AI winter, where progress seemed to stall.
But then we saw the rise of neural networks, which take a different approach, trying to model the brain itself rather than explicitly programming how to think. Can you break down how these networks learn?
Okay, so imagine a simple neural network. It's made up of interconnected nodes called perceptrons. Each perceptron receives multiple inputs, and each input has a weight attached to it. The perceptron adds up these weighted inputs, and if the sum is above a certain threshold, it fires, sending a signal to other perceptrons. The network learns by adjusting these weights. If it makes a mistake, the weights get tweaked, so it's more likely to give the right answer next time. Think about training it to recognize handwritten numbers. You feed it thousands of images, and it slowly learns to adjust those weights until it can consistently identify the digits.
But the early single-layer networks had limitations, right? That led to the development of multi-layer deep learning networks. They're incredibly powerful, but they also become harder to understand. It's like they're black boxes.
Right. Deep learning with those multiple layers can learn complex patterns from massive amounts of data. Convolutional neural networks, or ConvNets, are especially good at image recognition because they're designed to work like our visual cortex, breaking down images into smaller parts. Deep learning is behind a lot of the AI we see today, from playing games like chess and go to medical diagnosis, voice recognition, translation, even self-driving cars.
But current AI still struggles with things that seem basic to us, like understanding context or common sense. There have been those adversarial attacks, where a tiny change to an image can completely fool the AI. It shows how brittle that kind of intelligence can be.
Yeah, they lack the kind of background knowledge about the world that we humans take for granted. Think about this example. Alice says to Bob, "I'm leaving you." And Bob asks, "Who's her?" For a human, that context is obvious. We understand the implication of a romantic relationship and jealousy, but current AI, which is mostly focused on the literal meaning of words, would miss all of that.
It's like Douglas Hofstadter argues, real understanding requires having a mental model of the world, not just processing words. And Alan Turing's famous imitation game, the Turing test, isn't a perfect measure of thinking or having a mind. Just being able to fool a human doesn't mean the machine understands what it's saying.
It's like our sense of whether something is creative is tied to whether we think there's an intention behind it. We might react differently to a piece of art or music if we know it was created by a computer. Current AI doesn't seem to have that same kind of intentionality or creativity.
So will we ever have to acknowledge machine consciousness? Is it inevitable that as AI gets more sophisticated, it will also become conscious?
It's one of the big unknowns. Some people believe it's inevitable, some say it's possible but needs specific design features. Others say machines can never truly be conscious.
Ball suggests a practical approach. Maybe we should treat AI as honorary organisms with honorary minds to see what we can learn. And it makes you think about those fears of a robot apocalypse, like that idea of an intelligence explosion leading to superintelligent machines we can't even comprehend.
It's like in that movie Her. The idea is that once AI becomes intelligent enough, it could rapidly surpass human intelligence, leading to consequences we can't predict. But maybe our understanding of minds, as limited as it is based on some universal principles. Perhaps MindSpace, this map of all possible minds, could be like a periodic table of minds, showing us what's out there and what could potentially exist.
Imagining alien minds is a huge challenge. So much of science fiction just gives us humans with weird makeup or different environments.
Yeah, you see that a lot in those classic sci-fi stories where aliens are basically just reflections of ourselves and our own societies. Think of Edgar Rice Burroughs, or even parts of Dune, Star Trek, and Star Wars. It's more interesting when writers try to imagine truly alien minds, like in H.G. Wells' work, or Olaf Stapledon's Cosmic Consciousness.
And just detecting extraterrestrial life is hard enough. We don't even agree on what life means, let alone what an alien mind might look like.
Right. We're still trying to understand the conditions for life as we know it. But recent discoveries of things like water vapor on exoplanets are encouraging. From a biological perspective, natural selection seems like the most likely way for complex life to evolve, which could mean some degree of convergent evolution, like maybe flying creatures on other planets would also need wings.
But there could be huge differences in how alien life reproduces or passes on information. Things like epigenetics, or even the potential for directed evolution through genetic engineering, could lead to very different paths.
Absolutely. And the specific features of a planet, like its gravity or atmosphere, and the evolutionary history of a species, would all shape their minds. It's even been suggested that our level of intelligence might be a rare outcome, a fluke of sexual selection, and not something we should expect to find everywhere.
So the universe might be full of life, but not necessarily intelligent life.
It's possible. Wallace Arthur, for example, suggests that most inhabited planets might only have microbial life. And even if there are intelligent aliens, communication would be a huge challenge. They might use completely different senses and ways of signaling.
And the structure of their language would be shaped by their environment, and their way of thinking. It's like the complexity of human language is tied to the complexity of our thoughts and choices.
Yeah. It makes you wonder how we would ever decode a truly alien language. It's like those far out ideas of mind uploading, transferring our minds into computers. It's often seen as a way to achieve immortality or explore virtual worlds.
It's a fascinating idea, but the technological challenges are mind-boggling. Even if we could map every neuron and connection in the brain, there's the philosophical question of whether the uploaded mind would be the same conscious entity or just a copy.
Right. And what about those attempts to classify advanced alien civilizations, like Dyson spheres and the Kardashev scale? They try to categorize them based on their energy usage. But we need to be careful about projecting our own ideas about technology onto potentially very different alien cultures.
It's like science fiction often reflects more about us than about real aliens. Even Bostrom's simulation argument, which suggests we might be living in a computer simulation created by a more advanced civilization, is inherently anthropocentric.
It's hard to escape our own biases, but it's important to try. And it's both humbling and mind-blowing to consider the sheer scale of the cosmos. There's even the possibility that random fluctuations in the universe could have created exact replicas of our brains somewhere out there. It makes you question the uniqueness of our own consciousness and our reality.
It's enough to give you an existential crisis.
Yeah.
It also makes you think about the concept of God. If you take the traditional view of an external, rational creator, that's one way to think about a higher mind. But there are more abstract theological ideas, like David Bentley Hart's concept of pure intelligibility, that suggest a kind of ultimate reality that might not require a mind as we understand it.
And that brings us to the last chapter of Ball's book, where he starts with this thought-provoking sentence. Imagine a mind that has no will of its own. It makes you think about free will, one of those big philosophical questions that's been debated forever.
The materialist view, which is dominant in science, basically says our choices are determined by our brains and our past experiences. But there were more speculative ideas too, like John Joe McFadden's idea of a conscious electromagnetic information field in the brain influencing our actions.
But Anthony Cashmore argues that believing in free will is essentially believing in something beyond the physical world, like those old ideas of vitalism or dualism.
He says if our actions are just the result of physical laws, then true free will is an illusion. But it's hard to imagine that every thought we have, like deciding to make a cup of tea, is predetermined by some specific configuration of atoms in our brains. The brain is so complex that new properties emerge at higher levels of organization. You can't just reduce psychology to biology.
And minds definitely enhance our agency, our ability to make choices. We can think ahead, consider different options, and pursue our goals. In living systems, it's our agency that directs where atoms go, not the other way around.
So maybe free will isn't some magical force, but rather a biological trait that arises from our brains, including our memory, emotions, and conscious awareness.
Right. And those studies showing brain activity that seems to predict our decisions before we're even aware of making them are fascinating. But they don't necessarily prove that we don't have volition. We make tons of unconscious decisions every day, like flipping a coin.
And even randomness plays a role in living things, introducing variability that can be useful for survival. But it's important to distinguish between true randomness and genuine agency, which involves making decisions based on goals and feedback. Think of a simple bacterium that swims towards food. It's not just random movement, it's directed by a goal.